All right, there we go. So, all right, we're back to graphing again. We're still graphing. So a lot of what we're going to do this semester is graph. You guys are going to be graphing professionals by the time we're done with this course is the plan. All right, so you guys know what, not y squared, what y equals x squared looks like, right? What does y equals x squared look like? Yeah, it's parabola, it's a U shape, right? Centered at the origin. Whoops, not a very good axis, but there we go. Right? Totally right. Guess what y equals x to the fourth looks like? Yeah, pretty much the same thing. It just goes up faster, so it's, it's more narrow because it's going up quicker. But it's basically the same thing. It's another U shape. Basically what we're going to see in this section is anytime you have an even power, second power, fourth power, sixth power, eighth power, 10th power, all the even powers, basically y to any even power, if it's just simply that, is a U shape. The higher the power, the faster it goes up, but it's really basically a U shape. What about if you have odd? Now we already know what x to the third looks like. What does x to the third look like? It's the snake, lower left to upper right. What do you think like x to the fifth looks like? The same thing pretty much. It just goes up faster and down faster. So any odd power basically looks like x to the third, and any even power basically looks like x to the second. They're just doing it faster is all. So basically we're going to take what we learned then about graphing x to the second power and do it on any even power. So how would we graph then x to the fourth? What do you think x plus, so they're giving me really on this one here, let me go to a new screen. They're giving me x to, what was it? X plus 3, so y equals x plus 3 to the fourth. What's that little x plus 3 going to do? Left 3. So it's a U shape moved left 3. Which one of those think it is? A, B, C, or D? D. See how good you are graphing now? It's a piece of cake, huh? Right. The official way I'm going to ask you to do it on the next exam is just like I did on this one. I'm going to say, give me 2 points, give me the center point, and one other point. How do you always find the center point? Yeah, make the x zone 0, so that'd be what? What would I plug in for x to make that 0? -3. And then y would just be -3 plus 3. Am I on the screen? Yeah. To the fourth. So y would be 0. So today, like, the whole thing's on the screen, magically. And then tomorrow it'll be off. Anyway. So 0. So -3, 0, which is exactly the point they've got right there. And then what do you do to find the other point? Add 1. Right, we would just add 1 to whatever the first x value was. -2. Plug that in, you get something. This is going to be 1, isn't it? -2 plus 3 to the fourth. That's 1 to the fourth. That's 1. So -2, 1, which is, sure enough, see, there it is, -2, 1. Yeah, anyway, easy, right? I'll move on. So, all right, so what do you think? X minus 4 to the fifth power plus 2. So it's going to look like a snake, right? It's an odd power. So let me let you go ahead on your own papers there. Find the center point and one other point. Can you do that real quick? So find the new center. That one's important on that one. Find the new center there. All right, so what do I plug in to find the center? What x value? Everybody go, yeah, you just look right there at the x zone. You say, what do I plug in to make just the x zone, right? Not the 2. Don't worry about the 2. The 2's not, the plus 2 is outside of the x zone, right? The x zone is the parentheses, so +4. If you plug that in, what are you going to get? Let me see, 4 minus 4, excuse me, to the fifth. Excuse me, plus 2, so it's going to be 2. So 4, 2. 1, 2, 3, 4, up 2. There's the new center, right? Did you guys get that okay? Over 4, up 2. That's where normally the center's at the origin for all these graphs. This one's centered, has moved to 4, 2. And then how do we find the other point? Add 1. We just add 1 to the x value, right? Plug in 5. What are we going to get? Y equals 5 minus 4 to the fifth. Plus 2, 1 to the fifth plus 2. What's that, 3? 3 over 5 up 3. Right there? All right, does a snake, so, something like that. Through those 2 points. And we got it. Which graph is right? Is it D? A and D look a lot alike to me. You'd have to focus in and fool around, and I don't want to take time for that. So it's one of those. And on the test, I'm not going to give you multiple choice anyway. I'm just going to ask you to give me the 2 dots, and I'm happy. All right, so try that one. So y equals 2 minus x minus 3 to the 4th. So same thing. Find the center point and one other point. So plug in there. What x value are we plugging in? 3. That's what will zero out the x zone, right? Plug in a 3. So y equals 2 minus 3 minus 3 to the 4th. But just 2, huh? Over 3 at 2? So that's the new center. It's great the way we can just snap right away. We get that new center, huh? So over 3, 1, 2, 3, up 2, boom. There's the new center of the U shape. Over 3, up 2. Good. Now, what do you do to find the other point? Just add 1. This is easy, right? Add 1. Plug in 4. So what do you get? I'll bring it over here. So y equals 2 minus, what is it, 4 minus 3 to the 4th? That's going to be 2 minus 1, huh? It's going to be 1. Over 4 up 1. So here's the center point, and then there's the other point. We good to there? And what's the basic look of an x to the 4th? Well, it's a U shape. They're all, we can see it right there, A, B, C, D. It's a U shape because it's an even power. And we have the center at over 3 up 2, and the other point at over 4 up 1. So we make the U. Like that. Can you guys tell which one it is? Oh, yeah, they give me points. That's nice, huh? Yeah. We good? You guys thinking this is the easiest thing ever? X-intercepts. Good memory. Yeah, remember we're doing that in the calculator? The TI-84 often uses the word 0, and it means x-intercept. So when they say the zeros, what that means is, I'm going to do a graph, but you don't have to do a graph. It's not required, but I think it'll be good just to get us thinking, It's back here at -2, right here at 0, 1, 2, 3, 4, 5, and right here at 5. So that means it's some kind of a function that goes like boom, 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 or something, I don't know. It might start down, which I kind of missed. It does something like that. Maybe it starts up here and goes this way. I don't know. It goes through those spots somehow, huh? Does that make sense? So it's some kind of polynomial thing. Polynomial just means like x to powers, like x to the 4th plus 3x to the 2nd, or I don't know. Some kind of polynomial thing. In other words, it's not a weird thing like roots or natural log or anything like that. Some kind of polynomial. Well, they even said, form a polynomial. That's how I know, because they said so. All right, so form a polynomial, and it's got to go through those spots. So what is that? They want me to write out the x thing, like the x, whatever. So how do you know how to do that? Based on just telling me the zeros.
Set the zeros equal to x, each one of them, and then stop here, get it equal to 0. That's one way to look at it.
Yeah, I like how you're thinking, Robert. Exactly. Yeah. So what does that mean, Robert? It's going to actually happen then with what is going to be a factor, as it's called. Right. If -2 is a 0, everybody thinking like Robert's thinking? He's thinking correctly. He's thinking well, right? What x can you plug in? Well, that's not saying it very well. If you plug in x is -2, you're supposed to get 0, right? That's what it means to be a 0, right? So whatever this thing is, y equals, I know there's some kind of x plus something or minus something, so that if I plug in -2, and then there's other ones also, But one of them is if I plug in x as negative 2, it becomes 0. So what must x have next to it? Plus 2, correct. Everybody see that? It must be x plus 2 because I know because negative 2 is a 0. See that? See how that works? And then what about the next one? What about the 0? Well, that means x plus 0, because if you plug in 0, that's just, or just x if you want. I'm being kind of formal there. You can just call it x. And then third one is, I don't know, I can't tell. Is it 3? 5. Okay, 5. So this one, if you plug in 5, it's supposed to come out 0. So what must be next to that x? Negative 5. Yeah, so you just do the opposite sign next to each of them, huh? Must have those 3 things in it because, if we plug in those different x values, we get 0. Those things are all multiplied together. So if any one of them becomes 0, the whole thing's 0, y is 0. And it's working. Make sense? They're basically giving me the factors by telling me that. See how that works? And I'm done. Oh, now you might think, well, how do you know, Mr. Aaron, there isn't like some number in front or something? Well, yeah, let me ask you guys. How do I know? Let me ask a couple good questions, which maybe you're already asking in your own mind. So there's what we have. Do they want me to multiply it out? Yeah, they say simplify. I think they want me to FOIL it all out.
It's going to be an equation.
Yeah, I'm going to try to, maybe they don't. Anyway, before I get to that, how do I know there's not like another x? That'd be one thing I'd be wondering if I was you. I'd be going, well, how do you know there's not, okay, I understand that's there and everything, but how do you know there's not like more x's?
The degree of the polynomial is 3.
Good. The degree is only 3. That means the highest power. Yeah, it's only third degree, so there's only 3 x's. If you multiply those out, when we FOIL in a minute, x to the third, right? If we had another x, it'd go to the 4th. That'd be too high. So we know there's only 3 x's. Yeah. And now, how do you know there's not like a 7 in front? A number. We can't be any x's, but how about like a number? Leading coefficient 1. Right? They're giving us all we need. So yeah. Hey, let's try typing that in without foiling, because that'd be nice if we could save that time. Although I know you guys have nothing to do with your life but math, right? X plus 2. So what does multiplicity mean? It means how many of those? So in other words, yeah. Yeah, so in other words, okay, we have a 0 that's 9, so that means x minus 9. Multiplicity 1, it just means first power, or only one. You don't even need to put a 1, it just means one of them. All right, and then the next one, there's a 0 that is, what, 3? The next 0 is 3, so that's x minus 3, right? Plug in 3, it's 0. But multiplicity 2, which means second power, just means there's 2 of them. Degree 3, that is 3 of them. We're done. And I'm not going to type it in. Is that good to there? Does that make sense? Multiplicity just means how many? There's multiple ones. All right, it doesn't matter what order you put that in. So again, we're just taking the opposite. If they told me the 0 is 9, positive 9, I go x minus 9. Right? Because that means if I plugged in 9, it would become 0. It would be a 0. If they gave me a negative 9, I would have put x plus 9, right? Because that would be making it 0 if plugged in. All right. Again, we're becoming graphing pros. All right. So this is y equals this thing. Let me write it over here. Y equals negative 9 x squared plus 1 x minus 7 cubed. Okay, it says list each real 0. Let's do this. Let me just jump right to the graph. I do agree with the picture worth 1,000 words thing. Seems to be true. I think if we can just get a rough graph, there's a graph there, picture of this thing, I think all the questions will be piece of cake at that point. You can kind of get a general look at the picture. So let's do that. So how do we find the zeros? Let's start by finding the zeros. So actually, maybe we're not quite ready for that. Yeah, so we got to do the graph. We got to find the zeros. So what are the zeros? What are the things you could plug in for x and make the thing 0? Because those will be on the x-axis, right? What could you plug in here? Let's start with that. That one's easy. What could you plug in there to make that 0? Well, just 7, huh? 7 minus 7 would be 0. So that means way over 7. 1, 2, 3, 4, 5, 6, 7. There's got to be a 0, huh? Is that good? And let me just note, its multiplicity is 3. Let's write it for now. We're not sure what that means right now. We'll get to that. But for sure, the graph is going to go boom, or maybe it's going to go boom. I don't know if it's going high to low or low to high or whatever. But it's going to go through that point. It's got to. I don't know whatever else it does, which we'll find in a minute. But it's got to go through the point over 7 up 0. How do I know? Because if you plug 7 in, that part's 0 times whatever, whatever is still 0. Y is 0. Over 7 up 0. Huh, for sure. Okay, so now what about this x squared plus 1 thing? Yeah, what can we plug in there to make that part 0?
X squared plus 1 equals 0, solve for x.
Good idea. Let's do that. 1, 2, 3, 4, 5, 6, 7. There we go. Back to that one. Okay, yeah, good idea. Let's take that part. X squared plus 1 equals 0, solve for x. Okay, let me let you guys go ahead and do that real quick. Do that. You can factor if you want. Maybe that'd be an easy way to factor. I like that. You're right. I'm testing you. I'm leading you down the wrong path on purpose. That's what I do. I just try to fool you during lecture so that I won't fool you on the test. This is what I see very often on tests. You got to get that out of your system, or calculus will be a horrific experience for you. You can't be doing that in calculus. You won't last. Right? For now, it's okay, but you got a semester. You got to get that out. If you're still doing that at the end, you're not going to make it through Math 5A. That's not true. Do you know that? That does not factor that way. It does not factor that way. X squared minus 1 does. Yes, that's x plus 1, x minus 1. Foil it out. You'll see, that's right. That's true. That's not what we have, but that's true. But this is not this. Why not? Let's check it again. I've done it before. I'll do it one more time here. Well, I'll do it again later because it's really important that you know that. Say it's not, is it? It's not. It's got a middle term of 2x. It's not. So, I mean, I know that seems small. That's the stuff that kicks people out of calculus. It's not the calculus. It's the algebra. They don't know their algebra well enough. So if you are planning to go to calculus, make a strong effort this semester to learn all those little algebra rules well. That is the reason people don't make it through calculus, is algebra. All right, so that doesn't work. We can't factor that. Well, what do we do then? How do we solve the thing? Can we just solve it straight? Let's move the 1 over, or subtract 1, however you want to say that. Be negative 1, right? And then put a root over both sides, and it's imaginary, huh? So there's nothing real coming out of this piece. There's no real number you could plug in for x to make that 0. Think about it. Any number you plug in for x here, it's going to be squared. So it's not going to be negative. Even if it was negative before, it's going to be squared. So it's going to be 0 or positive. And then you're going to add 1. It's going to be 1 or bigger, isn't it? It's not going to be 0. This piece doesn't give us any zeros, does it? Does that make sense on that? So that piece doesn't give us any zeros. So there's nothing. I'll just say no real zeros. There's only imaginary zeros. Right? And that's why they said they're the real zeros. That's why they said that phrase, is they were hitting on that. All right, so list each real zero. So the only real zero is 7. That's the only x you can plug in. That's the only x-intercept. This graph, whatever it is, only hits the x-axis here. No, it never touches the x-axis any other time. Isn't that interesting? So it's either above, come low, or it's low, come high. One or the other. I don't know which. So let's see. How do we determine, what else? Determine whether the graph crosses or touches the x-axis. Oh, okay, let's talk about this. Yeah, I just said, hey, it's like this, boom, or it's like that. Really, though? Couldn't it do one other thing sometimes? Don't graphs sometimes come on down and go boing and bounce? Couldn't it do that? Does it have to pass through? Can't it bounce sometimes? It can. It can bounce. How do you know? How do you know whether a graph is going to pass through or it's going to bounce? Anybody know? Yeah, Robert. How do you know all this stuff already? Yeah, it's the degree of the exponent. What about the degree? Robert, do you know?
When it's odd, it should bounce the x-axis.
Yeah.
Even it should just touch it.
You just like studied that on your own? Oh, okay.
Yeah, I've done
Yeah, you're exactly right. That's exactly right. Yeah, so basically, if the power, so let me write that somewhere. If the multiplicity, it's a big word. Multiplicity odd, it's a pass-through. Multiplicity even, it's a bouncer. Bless you. It's a bouncer. Yeah, if it's an even power, multiplicity power, same thing, it's going to be a bouncer. If it's odd, it's going to pass through. Why? Well, before we say why, let's look at ours. We have, I just erased it. We have an odd power here, don't we? Ours is odd, so it's a pass through. Right? If that was a 2 power, it would be a bouncer. Well, think about what? What do 2 powers do? What does x squared do? Comes down and bounces, huh? Right? Odd powers do the snake. They pass through, don't they? Right? What? Because even powers make everything positive, don't they? Whereas odd are positive and then negative. Right? All right. So, yeah. So, therefore, we know it's going to pass through. All right. So, it was true. It's either going to be, it's not going to bounce here. It's going to be high to low or low to high, or vice versa or whatever. So, how do you know which one now? That's called the end behavior. You got to know what it's going to do at the end. And what we mean by the end, we mean like way, 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 way down here. 10,000, you know. What's it going to do way off to the right at like 10,000? How do you know? Can you tell? Can you guys tell? Just like look at that function for a minute. It's kind of messed up now. Let's look at it right here. -9 x squared plus 1. What if I plugged in like 1,000 for x, or just 100? Maybe getting too big. What if I plugged in like 100 or 1,000 or something for x? Can you tell? Is it going to be positive or negative? I mean, if you plug in a really big number. So let's just take y equals -9 x squared plus 1 x minus 7. If I plugged in something like 1,000 for x, what am I going to get? -9 times, I'll say big, right? 1,000 squared plus 1, it's 1,000,001. It's really big. And then this is 1,000 minus 7, which is 993, to the third power, you know, really big. -9 times big. It's going to be negative big, meaning it's going down. The end behavior, way off to the end, it's got to be going down. It's going down, 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 isn't it? That graph. Hey, how do we know that if I plugged in some really big number and it was, you know, really, really down? But how do we know it doesn't like? Am I saying it always goes? I mean, could it come back up for a while? Could it cross the x-axis again and then eventually go down? You're supposed to yell out with one accord. No way, Mr. Heron. How do we know? How do we know it's not going to cross the x-axis again?
There's no more zeros.
There's no more zeros. This is the only place it crosses the x-axis, remember? So if it's going down after that, it's never going to come. I mean, it might go up and down, wherever it's at, but it's not ever going to get above the x-axis again. Right? It's never going to get above the x-axis again. And eventually it's going to go as low as you want. It's just going to keep going down, down, down. And this part's going up. So that's all the questions they wanted. Oh, actually, you know what? They want you to put it a certain way. Let me make sure I answer it for you. Let's see. Did we answer? List the zeros. We did that. Determine whether the graph crosses or touches. That we did that. That's the pass-through bounce thing. They say cross or touch. I say bounce or pass through. Determine the maximum number of turning points. Maximum number of turning points. Yeah, maximum number of turning points. Yeah, the maximum number of turning points, whoops, I'm erasing that, is always one less than the power. Is that true? Yeah, that's true, huh? Yeah, so let me just mention, I need a new screen here. So let me do that. I didn't notice that particular question. Okay, max number of turning points equals the highest power, called the degree, right? Highest power minus 1. So in other words, if you have like a x cubed plus, 3x squared minus 7x plus 2 or whatever, some kind of x cubed thing, at most it'll turn twice. Now notice I say at most. It might do less. It might do less. But at most it'll have 2 turning points. If you have x to the 4th plus blah, 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 then at most it's 1, 2, 3. 3 turning points at most. So that's this. So 1 less than the highest power is the max number of turning points. So what is ours? If we were to FOIL this out, in fact, I need a new screen again. This one's got a lot of steps to it. So if I was to take our function, y equals -9, x squared plus 3, x minus 7 to the third. If I was to FOIL it all out, it would be a fair bit of work. I really don't want to do that. I don't want to FOIL it all the way out. But if I was to FOIL it all the way out, can you guys tell me what the front term would be? -9x to the 5th. Everybody see that? Because x squared is the biggest power here, and x minus 7 cubed, that really means x minus 7, x minus 7, x minus 7. So when you FOIL that all out, the biggest term would be the minus 9 times x squared times x times x times x. There'd be other terms in all the interactions, you know, but the most powerful term would be the one that comes from the most powerful thing here that multiplies the most powerful thing there, there, and there, right? That's going to be the most powerful term. So the most powerful term is going to be minus 9x to the 5th. Everything after that is going to be x to the 4th, x to the 3rd, lower stuff, huh? So this is going to be the leading term, and that also is why the thing goes down. Because you see, the leading term has the power in the end. He's the most powerful. Is that making sense? You catching my words? If you plug in 1,000 or 10,000 or 100,000 or 1,000,000 for x, the 5th power of that is going to overwhelm, at least eventually, the lower powers. Even if this has some giant coefficient in front of it. Negative 10 million, x to the 4th. I plug in a big enough number, he still wins. Because he's x to the 5th. He's going to multiply x 5 times. So, yeah, but that's got a 10 million. Okay, plug in 100 billion. An extra 100 billion. He wins, right? So eventually, there's always a point off to the right far enough, where that's what we call an end behavior, where the most powerful term will take over. The highest power term will eventually dictate the end story, right? So that most powerful term will win in the end. So that tells us it's going down eventually. And it's a 5th power, so it has at most 4 turning points, right? At most 4 turning points, which is the answer to part C. And the end, when they say end behavior, so that's part C. Part D, what they want for end behavior, the end, they just want you to go minus 9x to the 5th. They just want you to give them the front term, I think. If you look at that quick, they might say up or down, but I think they just want this. Is that what they want? Yeah. We good with all that? All right. Let's see.
So, the zero, you know the zeros that were imaginary?
Yeah.
They still are intercepted, but they just don't cross the axis, right? They just touch the axis. So, like if you were trying to graph that.
So the zeros are, say it one more time, Robert. The zeros that were imaginary, they don't cross the x-axis, true, and then what?
Yeah, like if we were trying to draw a rough sketch of that graph, we would still plot those, but they just don't cross the x, or they don't cross the x-axis, right? In order to, because they churn at some point, they still churn at the imaginary, right?
No, the imaginary is imaginary.
Okay.
It's not any, where would you go on the x-axis? It's imaginary. Yeah, no. They do mean something, but not that.
Right, that shows where they churn at, but it's not on the x-axis. I'm assuming that they would have to turn somewhere.
They have to turn somewhere, but where they turn somewhere is on the x-axis. So that it can't be the imaginaries, because the imaginaries aren't on the x-axis, right? I mean, I know there's something, I went to a conference one time and they said that there's something you can do with the imaginaries, but it's not quite that. I don't remember what it is. All right, so anyway, let's try this one. All right, what is x minus 1 to the 3rd, x plus 2 to the 8th? Can we, let's answer the question. First off, list each real zero and its multiplicity. Can you do that? So the zeros, the real zeros, are plus 1 and minus 8, multiplicity 3, multiplicity 2. We good so far? And then determine whether the graph crosses or touches the x-axis. So at plus 1 and at minus 8. Okay, so at plus 1, is it going to cross or touch? Right here at plus 1. Is it going to pass through, or is it going to bounce? In other words, my terms. It's going to pass through, right? It's going to pass through, or what do they call it? Cross. It's going to cross the x-axis, right? Why? How do we know? Because the multiplicity is odd, right? The plus 1 has a multiplicity 3, 3rd power, right? 3rd power. All right, what about at the negative 8? If the negative 8, is the graph going to pass through or bounce? That's a bouncer. So you could write pass through, bounce if you want, just because we're going to do a rough graph here in a second. Pass through, bounce. It's going to bounce at negative 8 because negative 8 has even multiplicity 2, huh? It's going to bounce there. We good with all that? Determine whether the graph, okay, we did that. Determine the maximum number of turning points. What's the max number of turning points? Part C. Max turning points equal 4. See that? Why? Because if you multiply this function out, it's going to be x to the 5th in the front, isn't it? If we do that, if you were to FOIL that all out, the most powerful term would just be just positive 1. You don't need to put the plus 1, but just, there's no other coefficient, huh? Just positive 1 x to the 5th. So remember, the turning point is always 1 less than the max number of turns is always 1 less than the highest power. All right, part D. What's the end behavior? Well, that is the plus 1 x to the 5th. It's the most powerful term determines the end behavior. So it's going up, up, and away, like Superman at the end. It's got to, right? That makes sense. So it must pass through here, come back up here, and bounce. That's a real rough, quick, general sketch of the graph, huh? So you just got to go up this way, up to the right. End behavior is up, positive. Passes through, bounces. So notice it's never above the x-axis. It's from 1 back forever. It's never positive again. See how much quick information you can know about that? You know, you just look at that function when your calculus is supposed to help you with, like your calculus, they give you some crazy function. You can right away just do this quick thing and go, oh, this thing is never, if they want you to find a max value or some kind of other thing in calculus, well, it's never going to be positive again after 1. I know it's just going to come down and bounce and never come up past the x-axis again. You know that much information that quick with these tools. Good there? Are we happy with it? At the end and I leave them. Not the best way to go. All right, so let's try number 9. List each real zero and its multiplicity. Maybe I'll do roll for a change. I'll do roll while you try that one. So go ahead. Try that one. I'll do roll.